Well, welcome everyone. And for the next hour or so, we'll be giving you an introduction into Vault for FeatureCam and PowerMill, allowing us to connect the design process to the programming to the manufacturing processes. So our agenda, we'll start with a quick introductions and a little bit on who we are at ImagineIt and what we do. We will then talk about the challenges in the current state of managing CAM data. We'll talk about a few of the main customer benefits and primary use cases for this solution. You will then see a live demonstration of the software, and then we'll close with some general requirements and some Q&A. So the presenters for today, myself, John Dow, I'm the Advanced Manufacturing Team Team Manager. I also have Tim Strandberg, one of our Senior Solutions Consultants, who will be providing the demo today. And then Ed Gilman's on the line as well to help answer any other additional questions that might come up. So just a little bit about who we are. ImagineIt Technologies is a division of RAND Worldwide. We are an Autodesk Platinum partner and a technology company serving the design and engineering professionals in the US and Canada. We have 4 internal divisions that provide unique services. So the ImagineIt division primarily focuses on the Autodesk related software, implementation, training, support, and consulting services. RAND 3D focuses on Dassault and PTC related solutions and training. RAND Sim focuses on high-end design simulation and analysis services. And then Ascent provides professional training materials for Autodesk, PTC, and Dassault products. ImagineIt itself focuses on a range of software and services. So from a professional services perspective, we do provide a range of consulting services, implementation services around your CAD, CAM, and CAE software, as well as implementation services for PDM and PLM software, so Vault and Fusion Manage. We also provide simulation analysis services for CFD and FEA, rendering and visualization services, process automation, and custom software development for design automation applications. From a training and support perspective, we do in-person training classes, live online training classes. We provide also private and dedicated training. And we also have a Productivity Now online portal that can provide technical support services and online learning management system at a user's request. Okay, so let's get to the meat of our presentation today. So Autodesk has introduced a plugin for PowerMill and FeatureCam to allow CAM projects and NC code to be managed within Vault. This plugin is known as Vault for Make. FeatureCam and PowerMill provide expert CNC programming tools for complex manufacturing, and the software generates the NC code. Vault is a product data management or a PDM solution that provides file management capabilities. Everyone works from a central source of organized data in Vault, allowing for collaboration, reducing errors, and saving time. So currently, many CAM customers do not have adequate tools to manage their CAM project files. All too often, companies work in data silos or departments, while the CAD files tend to be well controlled, like for Inventor and Vault, for instance. CAM projects and NC files are not controlled. They're usually just passed over the wall. CAM project files have additional challenges like little to no traceability from engineering to programming to machining. No linking of files from CAD to CAM to the NC code. They also do not do well when it comes to revision control or lifecycle management capabilities in an uncontrolled environment. And there's little to no feedback loops, knowledge sharing between teams, groups, or departments. So what if? What if the engineering department changes a model? They create a new revision. How does programming know so they can update the tooling? What if the CAM programmer sees an issue in the model's design? Let's say a design for manufacturability issue. How is that communicated back to engineering so that they can make changes? And what if the NC code was edited by the machine operator? What happens to that file? How does programming know of any changes that were made? What does this all cause? Since change is usually communicated manually in these environments, communication typically breaks down. Poor communication can lead to files not getting updated or being out of date for future work. It can increase costs related to rework, scrap, and wasted time. In other words, there's little to no feedback or traceability within the current workflow processes. So what's the solution? A new plugin called Autodesk Vault for Make. Vault on its own can remove the barriers or walls that separate departments. Any changes upstream can provide feedback and traceability to downstream stakeholders. Likewise, any downstream changes can provide feedback and traceability to upstream stakeholders. By improving communications, allowing traceability and feedback to everyone involved in the workflow process. So for instance, as a CAD designer releases the engineering model to be worked on by the CAM programmer, in Vault, its revision and lifecycle controlled now. The CAM programmer can import the released model into FeatureCAM or PowerMill to set up the tooling and generate the toolpath and NC code, which can also be released to the shop floor for machining. The shop floor, the machinist, can use a standalone tool to retrieve the files from Vault and send directly to a machine controller, all while providing a tight feedback and file traceability within the Vault system itself. So this is an example of a Vault Pro file workflow or a lifecycle definition and how it might relate to a design to manufacturing process. Again, this is just an example, but this example shows multiple file states and transitions over 3 phases of a workflow. So you have your CAD design phase, you have your CAM design phase, and you kind of have your production or your manufacturing phase in the process. So it shows which software or processes are being used in each phase. So you can kind of see the relationship of how Vault can interrelate between those different phases of the production and the workflow process. It's this process that allows us to control the feedback and the traceability needed, bringing the CAM project and manufacturing into the design and data management workflows. So let's talk about a few of the primary customer benefits. So we've kind of alluded to a few of these already, like traceability to the CAD files. So in other words, we have links now. When files are checked into the Vault, there's links that are created between the CAD file and the CAM projects. There's revision control on the CAM project files, the NC files, and the option files. Likewise, there's lifecycle states on the same CAM files as well. So now people can see when things are work in progress, they're in review, or they're released, and they're ready to be manufactured. Vault will also provide the interface for notifications and feedback so that you can always ensure that you have the latest status of the files that are in Vault. A standalone shop floor application allows for the delivery of released NC code files to machine tools directly from Vault. And then ultimately, it's the centralizing of the storage and the relationships of the CAD, the CAM, and the shop floor processes that you'll benefit mostly from with the Vault for Make application. So let's just talk about a few of the primary use cases here. So CAD file traceability. Again, we've hit on all these a little bit already, but CAD file traceability, you can be sure you're using the latest CAD file during any of your processes, especially during the manufacturing process. You'll have features like import from Vault to get your CAM project started with released Vault parts. Once your CAM project is completed, you can check them into Vault, and Vault will retain all the file relationships. If the CAD file changes or a new revision is released, you will be alerted of changes in the add-in. Then using the update to released feature, you can replace the model so you can calculate new toolpaths. NC code file traceability. Now you can automatically track the NC files created from your CAM projects in Vault. When you check in your CAM project, all related files, including the NC files, are checked in too. When a project is released in Vault, the NC files are released automatically as well, keeping your project in sync. And lastly, shop floor links to Vault. So now you can transfer NC files directly from Vault to machine controllers. So there's a special standalone application, a special Vault client that you can run from, say, a machinist workstation that allows them to search for and send NC files to the appropriate machines. This functionality works with all major controllers. Visual notifications provide feedback to the operator, ensuring they have the latest files and know the status of those files. The operators can also check out, edit, check in, and release NC files from this client as well. Okay, so next, we'll show a demonstration of Vault for Make, covering these primary use cases and workflows. So we'll be using FeatureCAM for this demonstration, but the interface and the functionality is basically the same for PowerMail. So Tim, I'll turn it over to you.
Well, good afternoon, everyone. Here is the part that we're going to program today. This is in Autodesk Vault. File was created in Inventor, just a simple hub. It's got a hole pattern, a wrench flat, a few steps in here. So we're going to jump over to FeatureCAM. And since this has both turning and milling operations on it, we're going to create a new turn mill project. And we'll skip through the first couple of dialogues here and get to the important stuff. As John mentioned, we can import directly from Vault. We don't have to worry about that CAD engineer emailing us the file or slipping it to us on a memory stick, whatever the case may be. We can talk directly to Vault. You notice up here at the top, it shows my connection. I am actually logged into Vault from FeatureCAM. So I choose my CAD file that I'm going to machine. And I might point out, it pops up, here's some of that feedback already. It says you imported a file from Vault. This file is released at revision A. Had I chosen a file that was not released, the plugin would have warned me that that the inventor file or that the original design file would not be tracked, meaning that as a CAM programmer, I would not be notified if that part went under revision because I didn't reference the latest, greatest released revision. So we'll go through here and quickly set up this part for tooling. Got to make a few changes. And make one final change here. Since we've already turned it down, we don't need the rough pass. So there I've got just that quick, I've got the basic setup to machine this part. So we're going to go ahead and save this part. It's going to save it to my local working directory. So we saved that project. Now, if I bring up that plugin again, we can see that, yep, we got the green check mark. It's fully recognized that solid. We're ready to go. So I'm going to go ahead and check this file into Vault. Check in that project. Tells me that, yep, everything's good to go. Project is now read-only. And I'm also going to change the state, the workflow state, to CAM work in progress, because we're developing the NC code. So instead of an engineering work in progress, we've got a CAM work in progress. Now I'll check the file back out so that I can edit it again. This out of my way for just a second. So there's our part, just like we saw in Vault. And we'll run a quick simulation just to make sure that we got everything. Okay, everything looks good. I didn't see any collisions. I didn't see any tool holder crashes or anything. So we're going to save that NC code that it generated. And this again is part of the plugin. The plugin, I should say, interacts with this. So we can choose all the different file types that FeatureCAM offers to be able to save off all of our tool data, all of the setup data, machine configurations, so on and so forth. Most importantly, our NC program down there at the bottom. So we'll go ahead and click OK. And all of our files were saved again to our working folder. If I would take a look again at our plugin, now we can see down here at the bottom, here's all of those files. There's our option file that matched what I had set up over here originally in FeatureCAM. So now it's time to, again, check in those files. This time it's plural because we're not only checking in the project, we're checking in all of the files that go along with it. And so since we're done programming, we'll change that state to manufacturing released. We would hop over here to Vault and refresh our screen. Oops, get in the right folder. There we can see our project file, our FeatureCAM project file. We see it's manufacturing released, as well as the folder that it created. Again, there's our NC file. It is also released. The third tool that we're going to use here, in addition to FeatureCAM and Vault, is this Vault for NC files. This is a standalone tool. It's got it. You need to log in, so it consumes a Vault license. You need to log in, just like any of the other Vault clients. So it authenticated with the server. We have the ability to configure any number of machines, and this is primarily, if you remember on one of John's slides, this can use a proprietary protocol. It can write out to a network share, wherever that machine can read it from. So today we're going to write to the HOS, and now we need to add that NC file to the mix. So we look in our CAM folder, in our subfolder. There's our NC file. And we can see that it lists the file, tells me it's manufacturing released, Rev A, there's the project. Everything looks good. So I'm going to go ahead and send it to that machine. So it tells me, yep, made the trip. Let's go look at that file. And there's our NC file. Everything looks okay in here to me, but I think I want to add an additional comment up here at the top. I'm the machine operator now. I'm Ed, the machine operator. So I add that comment, I'm going to save that file, close out of it, go back here. Oh, but wait a minute, now we're out of sync. The machine operator has changed that file. If we hit the refresh button, we can see more feedback over here. Nope, big red exclamation mark. The NC file in Vault is not what the machine has, or vice versa. So I'm going to change that state back. If I select it, change the state back to CAM work in progress. And now I'm going to read back in from the machine. So it's going to go out there on the network, grab the edits that my machine operator made, and read those back into the system. Now, if I would choose edit right from here, we can see, oh, there's our Vault for Make comment. So everything looks good there. So we will go ahead and check this back in. Now we've got the green check mark again. The NC file in Vault and the NC file that the machine has are exactly the same. Finally, we'll set this back to manufacturing released. Notice that since we made a change to that NC file, it changed the revision on that NC file. It also changed the revision on the CAM project itself. We'd go back here to Vault, refresh the screen, and take a look at our NC file. If I go ahead and open that file, no, I don't want to check it out. There's our comment. So we made the full round trip, changes all included, everybody's happy. And with that, back to you, John.
Thank you, Tim. So just to wrap up, a couple more things here. There's a few things you need to be aware of when it comes to using Vault for Make. There's some general requirements. So first and foremost, it does require Autodesk Vault Professional or Vault Workgroup, the 2020 version or higher. So if you have Vault Pro or Workgroup, you're pretty much good to go. If you do not have one of those two flavors of Vault, then you'll need an implementation of Vault first. Okay, so some of the things just to be aware of if you do not currently have Vault. So you'd need a Vault server. Along with that server is going to be some operating system software and SQL Server software, licensing for the Vault Pro and SQL Server if you're using SQL Server Standard. There's some installation and configuration that would be required, and some training and possibly some post-implementation support if needed. Likewise, you're going to need the FeatureCAM and or PowerMill software. Okay. And with your Vault subscription, you'll be able to have access to the Vault for Make software. This becomes an entitlement with that subscription. So in other words, you get the Vault for Make software for free. Now, the only thing you have to be aware of there is that depending on the number of users that will be using the Vault for Make software, you may have to up your Vault license count to be able to support those additional users. And then the last thing is the implementation service around Vault for Make. So it's pretty straightforward. There's some installation and configuration required and some user training. So typically, we range the basic implementation from between about 1 and 3 days, assuming you already have Vault Pro configured and implemented or Vault Workgroup. And then the variance just comes in depending on how many different machine controllers there might be, depending on if there's any necessary other configurations that could extend that out. But that would all be determined during pre-sales. So that brings us to the end of this presentation, and we can now open up for any questions.